Hello friends, you all are welcomed in the Collegiate-Physics classes in lecture number 6. Today we will show the importance of center of mass frame of reference. Suppose that we have to study the collision in a plane. This is also called collision in two dimensions. Perfect elastic collision in two dimensions. Suppose that we have to study the perfect elastic collision in two dimensions. For this, suppose that the mass of first body is m1, its velocity is u1, the mass of second body is m2, its velocity u2 is equal to 0. For simplicity, we have assumed that this second body is at rest and the first body is colliding against this second body. This collision is not head-on collision. So, after collision, suppose that this line is x-axis, m2 is at rest and m1 is making a collision. This collision is not head-on collision. So after collision, this m1 body moves with velocity v1 at angle θ1 from the direction of x-axis. The second body m2 moves with velocity v2 at angle θ2 from the direction of x-axis. Now we have to study the parameters of motion of the two bodies after collision. To find the value of v1 and v2, we apply the law of conservation of momentum of this system along x-axis. So, before collision, the momentum of the system along x-axis will be given as when we apply the law of conservation of momentum along x-axis, then before collision, the momentum of the first body along x-axis is m1 u1. The momentum of first body along x-axis after collision will be equal to m1 v1 cos θ1, and the momentum of second body along x-axis after collision will be m2 v2 cos theta 2. This is the equation which is obtained by applying the law of conservation of momentum along x-axis of this system. Again, we apply the law of conservation of momentum of this system along y-axis. That is, before collision, the momentum of the system along y-axis will be 0. And after collision, the momentum of m1 along y-axis will be m1 v1 sin theta 1. And the momentum of second body after collision along this y-axis will be m2 v2 sin theta 2 The momentum along positive direction of y-axis will be taken as positive, and the momentum along negative direction of y-axis will be taken as negative. So these two equations have been obtained by applying the law of conservation of momentum along x-axis and along y-axis. Now the third equation will be obtained by applying the law of conservation of kinetic energy. That is, before collision the total kinetic energy, and after collision the total kinetic energy of the system will be constant. So half m1 e1 square is equal to half m1 v1 square plus half m2 v2 square. This is equation number 3. We have only 3 equations as given on this blackboard. But after collision, to study the motion of the system, we have to find v1, v2, theta 1 and theta 2. Then we can find all the parameters of this collision after collision. But we have only 3 equations and the variables are 4. v1 is one variable, v2 is another variable, theta 1 is third and theta 2 is 4. So we have to find 4 parameters and equations are 3. In this situation, we cannot find the value of these 4 parameters v1, v2, theta 1, theta 2. These cannot be determined uniquely. Any one of these 4 variables will be assumed constant, then the rest 3 can be determined. But uniquely, these 4 parameters cannot be determined because the number of equations are insufficient. So, this is the demerit of L frame of reference. I have discussed this problem in laboratory frame of reference. We can say that if we apply laboratory frame of reference, then the collision in a plane cannot be studied completely. But if the same problem is studied in center of mass frame of reference, then we will see that these parameters can be very easily studied after the collision. This is the difference, this is the distinction between L frame of reference and C frame of reference. So, to study such problems, we apply C frame of reference or center of mass frame of reference, and that will be explained in the next lecture, that is in 7th lecture. The note of this question is given in the same video. You can read that note regarding this problem. Thank you for attending the class. Thank you.